We have this question over here about transformations. We are given the transformation y equals to xv, and we are given in part A to turn this equation in terms of y and x into this equation in terms of v and x. So we have to remove y from this using this transformation we are given. So at first we see that in here we have dy by dx, here we have dv by dx. Dx is at the bottom, so we differentiate this term y equals to xv implicitly in terms of x. Get this. And for the right hand side we need to use the product rule, which is the derivative of x, which is 1 times v, and then x times the derivative of v, which is dv by dx. Now we also have d squared y by dx square in this term, so we have to differentiate dy by dx again with respect to x. And here for the second term we use the product rule, where we have the derivative of x, which is 1 times dv by dx, and x times the derivative of dv by dx with respect to x, which is d square v by dx square. Now we need to substitute this into this equation over here. Let's do that. At first we can simplify this to dv by dx. Look at that. We have 3d square y by dx square. We substitute that. We have minus 6 by x dy by dx. We substitute dy by dx, and we substitute these y's over here. This x cancels out over here, and this cancels out, so we can write it. So let's start from the start. So we have 6 dv by dx plus 3x d square v by dx square. Then we have minus 6v by x. Then we have minus 6 dv dx, and then we have plus 6v over x, and the rest. We see that these and this cancels out with this, and this cancels out with this, so we can cancel this out, and then we get this equation over here. We can divide the whole with x, and we can get this, and this is the equation that we were required to find, and we have shown that, and that's the answer for part A. For part B, we need to find the general solution of the differential equation we are given with over here. To work with it, this is easier to work with, and we find the general solution by finding a complementary function using the auxiliary equation and using the particular integral from the right hand side. So initially for the auxiliary equation we take v to be e to the power mx, and then we find the auxiliary equation to be 3m square plus 3 equals to 0. We get m square equals to minus 1, so m is plus minus I, and the complementary function would then be a cos x plus b sin x, where a and b are unknown constants. And then for the particular integral we take v to be ax plus b, and then we find dv by dx and d square v by dx square, which would be a and 0 respectively, and then we put these values into this equation over here. So by doing that we get this and we compare it. So 3a would be equal to 1 and 3b would be equals to 0. So we can assume that a is a third and b is 0. So the particular integral is v equals to a to the power a 1/3 x, my bad. V is 1/3 x, and the complementary function is a cos x plus b sin x. The general solution would be the sum of the complementary function and the particular integral, and we get the general solution to be a cos x plus b sin x plus 1/3 x, and that's the general solution that we are required to find out in part B.